Yeah, so I'll be talking about HTML5 Canvas today. Canvas is, there's a couple graphics rendering technologies you can use when you're doing web graphics. If you're using D3, you probably already played with SVG, scalable vector graphics. SVG is sort of DOM-oriented, so it's kind of like writing HTML, right? You're writing a nested XML document. There's WebGL, which is just a whole huge mountain of learning curve that you probably haven't gotten too far into if you're here tonight. And then there's Canvas, which is super simple, just sort of graphics API that is not it's not document-based, it's not XML-based. You just draw into a canvas. And it's super simple, so I was just going to get started, show you how to use Canvas. I think the very best, if you're not familiar at all with Canvas, start recording here. If you're not familiar at all with Canvas, I think the very best tutorial online is actually, and I never say this except for Canvas, is W3 Schools. Is really quite good, actually, Canvas tutorial. Canvas Elements is used to draw graphics on the fly on a web page. This is exactly right. Creating a canvas is super simple, so let's just go through this tutorial right now because it's so simple. Canvas tutorial. Just increase the font size here. So the first thing we need is a canvas. And it needs to have an ID. We'll call this our painting. It can have a width and height. And that's it. Why not? Zoom out a little bit here. So just do this. Oh my goodness. That's it. That's all the. That's actually really the only DOM element we need. It's just the canvas element. And then there's a little sort of boilerplate that's super simple. To get started rendering to the canvas, you have to select the elements. Very simple. And then you get the canvas rendering context, which is get context 2D. And that's it. Let me just change the theme of my editor so you can actually read the text here. Preferences, basic. OK. Let me just get out of this. Use this one. Did I not save that page? Ah, OK. Well, then I'll just copy and paste it from. Just copy and paste this over here. OK. And I need one of these guys. OK. So this is like all you need to get started. Let's open up this page in the web browser. And then you're able to draw. So let's just quickly run through this tutorial to give it a sense of like what kinds of methods on the canvas context. So pretty much everything we'll be doing is a method on this 2D context. Or is an attribute of the 2D context, which is how we style the canvas. So the canvas context is a stateful element. You set the fill. There's no CSS that's going to get applied to your canvas. You can't style it after the fact. It's just it has a style, which is its internal state. Everything you render while the style is set to that, which I'll explain in a minute here. So if we want to set the fill style here. Set this fill style to, what's a nice blue? Pale blue, is that a blue? Give me a CSS color. Steel blue. We set the fill style to steel blue. And we can fill a rectangle here. So fill rectangle, this is actually just going to render a rectangle on the page. It takes 4 arguments. It takes x. So let's throw it at 20. It takes y, put it, or 50 rather, 50, 50, width 20, height 20. So you should get a little steel blue square right there. So we're there. We're drawing on the page. It's super simple, right? It's only like, we only have like 6 lines of code here, or 7 lines or something like that. So super simple to get started drawing. Let's go through some other. So we have rectangles. We can draw rectangles, which I'm sure you're super excited about. Lines. We start lines with. Do we have to do begin path first? I guess not. So to do a line, you have to start somewhere. So let's start right at the corner of the circle we just drew, and let's draw a line to maybe the corner of the canvas. How about that? So we can get the canvas width and height. And if we stroke that line, it's a little black line that goes to the corner of the canvas. Use a larger canvas here. That's how you make lines. Very exciting. There's not a circle function, but there is an arc function. So this is where I'm not always 100% sure when you have to begin a path, but the beginning of a path here. So arc, I believe it still takes an x and a y. So let's just draw it in the middle of the canvas here. I think the next argument is the radius. So let's make it a nice big arc. And then this is the start and end angle. So it's 5 parameters, I believe. Let's try to. So if I don't do any fill here, it will sort of trace out this arc, but it doesn't render anything in there. It's not creating an element. It just goes, just kind of. Well, I don't know exactly what it does. It doesn't do anything unless you actually fill something. So if we inspect, unlike a normal D3 visualization, right, where let's find a normal D3 visualization here. Stock. So this is probably a SVG visualization. If we inspect the element here, right, all of these visual elements. All the visual elements in the page are literally elements in the document, right? And we can see them changing all down here. In a canvas, this all you're doing is rendering pixels. So there is no element changing. It's just the canvas sitting there. It's kind of like an image where you can change the image, but it's not creating anything inside, putting anything on top of it. It's a very simple little API. So to make a full circle, we just sweep out to 2 pi. So I like Canvas because it's kind of it's really nice for beginners, and it's really good just to like learn some basics of JavaScript here. So here, let's just do a basic JavaScript thing. Let's take this little bit of code we've written that makes a circle and just turn it into a function that is a little more readable. So we want to make a little function circle here. We give it an x, a y, and a radius, right? Something a little simpler and more readable than this little block of code here. And so this is our function. It doesn't need to return anything. It's all side effects, Canvas. It's all imperative programming. And now we have a function that we can call. We can just kind of put circles wherever we want. Put circles, we put a circle there, and we put a circle over here, and then a circle down here, right? So that's kind of like how you use Canvas, right? It's very simple, really elementary building blocks that you use to build your visualization. And that's kind of what's sweet about it. Let's just go through a couple more of its basic stuff. It's got text, super boring. There's gradients. You can put images on here. So you can draw an image data. You can grab an image from an image tag and draw it into your canvas and mess with its pixels. We'll check out some compositing mode stuff later. But that's it. I would just play around with this stuff and just get a sense of the basics of Canvas because it's really so easy to get started here. And then the trick is just, I mean, this looks pretty dumb, but the trick is, how do we make something interesting out of it? And that's where kind of D3 and functional programming comes in to kind of make some magic happen. So let's try. Let's actually bring D3 in here. Let's see if this errors out or not. So this function right here is almost sort of like a function that sort of takes an element of data and renders it out. And in fact, it could be a little more like that, a little more like a D3 function, right? If it took in as its arguments D and I, and if it looked at for attributes of this one data object. As how it renders a circle. So let's make some data that looks looks like this. So this block of code here, so here we're going to go through some simple D3 utilities. So D3.range, actually I'll run this in the console. OK, so D3 has all kinds of components to it. If you're learning D3 for the first time, you're probably learning selections first, selections and transitions and data binding and stuff like that. And today we're really just going to skip all that and just use totally the purely functional parts of D3, data utilities, and stuff like this, because we're not going to be dealing with document elements at all in the canvas. So D3.range is a little utility function. What it does is you just give it the start and end values, and it just gives you an array incrementing up. I think you can also pass it, oops. You can pass it a third argument to say what you want the interval to be. So this is going to give us, just go from 0 to 20. Or you know what I hear? Let's go to from 0 to the width in increments of 20. And we'll put that as our x value. We'll put the y right in the middle here, height divided by 2. And then the radius, let's try d times, nope, that's going to be huge. Let's try d divided by 20. Anyone know what this is going to look like? Oh, and not, this actually won't draw anything. So for each one of these elements, we're just going to apply the circle function. Anyone know what this will look like? Nothing, because width is not defined. Canvas width and canvas height. So it's just a bunch of little growing circles here, right? So we walk through this code. So what map does, the map function here, so if we have values like this, actually let's just go from 0 to 4, and we map, let's map actually like Math, yeah, I guess square root. Oh, won't do the last one, huh? 17. So if you have an array, in this case it's 0, 4, 8, 12, 16. And then you map a function. What it does is gives you an array the same size back, just with that function applied to every element. So what this little block of code here is doing is it's giving me an array from 0 to the canvas width in increments of 20. And then I'm mapping this function. And all I'm doing is returning an object that has these 3 values. And this last part here just takes every one of those elements and just applies this circle function down here. And the radius is just increasing here because this is a function of I here, right? If it was like this, it'd be a constant radius. If it was 20 minus d to 20, it'd be decreasing. So that's that. So let's make a grid here. Grids are usually a good place to start when you're. So I'm just going to nest one more loop in here. This one's going to go to the canvas height. Oops. Now let's just call this x and this y. These are not variables over here. I'll put them in. These are just properties of an object. Oh. Divide by 0. What did you say? Oh, it's just to distinguish them from these guys over here. Can I read property x of undefined? Oh. Oh yeah, this is an ugly way to. So now I have an array within an array, so I'm just going to get rid of these maps and call this for each. And apply the circle function right here. Well, that's a beautiful bunch of circles. Oh, let's just get rid of the stuff that I did up here. I'll just keep the blue color. Okay, we've got a grid. Let's just start it at 1, so it's not doing a bunch of circles cut off here. Wait a minute. Why won't that?
Radius is 5. So
Oh. Sort of. There we go. Okay, so when we have a grid, I mean, grids are cool because it's sort of a coordinate system. So we have sort of x and y coordinates, and I mean, if you really zoomed into a display, right, it's also a grid of pixels, right? And it's got x and y coordinates, and every pixel has RGB values. And when you're working with Canvas, that's basically right what you're doing is you're going into the computer's pixel display and you're modifying pixels. We're going to make them big here just so we can sort of play around and see a little bit of what's going on. And I was thinking maybe the thing we could investigate is D3's color space utilities, because they're really fun to play with Canvas. So let's jump to some examples of using D3's colors that are a little more intricate and interesting. So this is a zoomable Julia set. And it's just one that I made that I based on Doug X's Canvas fractals. So Doug X made this really nice fractal explorer built in Canvas. and just canvas. There's no libraries or anything here, where you could zoom into Julia fractals, Mandelbrot fractals, and various fractals by drawing these bounding boxes. There was no way to get out, and like you can't zoom out in any way. The color palette is, I mean, it's fine. I was just interested in sort of a richer color palette to see more of the detail. And so what I did was I used just a couple of D3 utilities. I used the HCL. Where's HCL? Hue, chroma something. Lightness?
Luminance?
Luminance. Color spaces. So this is what we're going to be exploring in a second here on our 2D grid. So color spaces are, oh man, it looks really different on, it looks really different up here than it does on my screen. There's no like red on, I feel like it's going to red on this display, but on my screen it just goes to blue. But yeah, HSL looks all wrong up there. It looks like some sort of rainbow thing. Anyways, HSL is, that's hue, saturation, lightness, I believe. So HSL is a color specification that's available in the browser. Actually, so without D3 at all, we can say, we can specify colors as HSL here. So hue, I think, goes from 0 to 360. I think 0 is red. Saturation, are these 0 to 255? I think it could be 0 to 1, or sometimes it's percentage signs. Let's see. 50%. All right, thank you, browser makers, for people specifying these things for all different. So hue goes from 0 to 360. So if we change the hue here, 30, we get a slightly different shade of, a totally different shade, actually. So the cool thing about Canvas is as we're rendering, we can kind of stick this fill style anywhere in our code, and it'll, if we stick it inside one of these loops here, so I have two loops. The top loop is just going from left to right and iterating, basically between columns. You can kind of think about it. It's just going through numbers, but conceptually, we're moving through columns in the outer loop, and in the inner loop, we're moving through rows. So if I do that, yeah. Wait, no. It should be fine. X. Yeah. I got a quoting problem here. Yeah, so let's divide by, you know what's the easiest thing is actually just to make the canvas width 360. And let's see, if I do 100% lightness, is that white? That's white. Okay, so that's iterating through hue. If we move it into this inner loop, now we can have both the X and the Y available. Let's apply one of these to saturation, maybe. So, and this one, I don't want to make it super skinny, so let's do canvas height divided by 4. So I'm just doing this, not canvas height, Y divided by 4. I'm just doing this so that the range of, well, maybe I should make a D3 scale. Doing this so it goes from 0 to 100, because the maximum height is 400 of this whole thing. And I think this has to be a integer, so let's just do that. So here we have a nice little thing that's sort of increasing its saturation as it goes down. It's kind of a gradient. if we decrease this number right here, right, what will that do? Anyone remember what this number does? The increment. So if I drop it down, I'll get more circles. Exactly. And if you dropped it down all the way, right, to 1, I mean, then we might as well just be coloring individual pixels instead of making circles. But right, it's almost a. I mean, the code I've written is a really. I mean, it's not a good way to render every. We could literally just iterate through every pixel instead of drawing little circles all over the place. But yeah, so there must be. I wonder how many circles there are actually here. Let's just make a counter here. Counter 0.
360 times 400.
Oh. What happened there? All right, there's like 136,000 little circles that were rendered. So the cool thing about Canvas is because it's not, so if you tried to render 136,000 SVG circles, the page would just sort of crawl like, I mean, it would just, your computer fan would start spinning up, and I mean, your whole computer would just come to a crawl because every SVG circle has all these, it's just like a div or a span or a link or an image, right? It has all these, it has all this infrastructure and architecture around it. It's got events you can listen to. It's an element on the page that sort of has persistence, right? You could select it again and do, change it. Whereas all the circles here, once they're rendered, they don't really exist anymore. I mean, it changed the color of the canvas and it moved on. So it didn't create 136,000 things. It just sort of rendered 136,000 circles, which are now so small that they're basically pixel density. And so, I mean, one of the cool applications of Canvas is just sort of rendering a ton of stuff, just getting it all on the page, which sometimes with SVG is a little bit painful to do. OK, but we're talking about color spaces here. So this is the HSL color space. From X to Y, we're going along the hue dimension, and from left to right. And then from top from bottom, we're going along the saturation dimension. We could change this to, if we fix saturation here, change this to lightness. Yeah, that worked. This is going through lightness. So lightness at 0 at the top, 1 at the bottom, or 100% at the bottom. But D3 has other interpolations for color space. So we can use this here by, instead of doing, we've got D3 loaded. So let's just load up a color here. Var color equals d3.lab. And then this is where I have no idea really what the domain of the lab space is. Maybe it's -100 to 100. But we can use Canvas to experiment and find out. So let's just put X and Y for the first 2 parameters of lab. LAB. What does LAB stand for? Is this toString? Is that how I get the color out of here? Only one way to find out. Huh. OK, let me just put this back to a more sane sort of number. So the thing about like So LAB and HCL, I think HCL, they're perceptual color spaces, and for various reasons, and I'm not 100% sure how they work, but there's part of the color space, like if you try to put it in a 3D block where it doesn't exist. So HSL, right, it's basically like a cube, and anywhere you pick in the cube of HSL, there is a color that sits there. LAB is not the same way, which is kind of what you're seeing up here, right? It just falls off, and there's no colors there. Just trying to figure out how to. I wonder if it's. Looks like there's stuff in the negatives here. I bet it's negative 100 to 100. So if we start at negative to 100, we could look in the documentation, but that's no fun. Yeah, sure. Okay, so what I'm trying to do clumsily here, and what Ian suggested. So let's actually just let's go to the documentation and find this for real. Oh, it's undocumented. Oh. Is HCL documented? No. All right, let's find out on the interwebs the lab color space. I don't know if these color spaces are like domain is what I want. Oh yeah, negative. Looks like negative. Oh, I know. Well, look, there's zeros in the middle. So, all right, let's just play around with D3 scales and we'll figure it out. So let's make an X scale here. Call it capital X. So scales, the exact same thing we use scales for in SVG. We would use them in Canvas for the exact same purpose. So the issue here, why we're going to a scale is that the lab color space right, has an input domain. And we want to take our screen coordinates, which is kind of the domain we're starting with, and output from screen coordinates a value that's inside the domain of the lab color space. It may not be a valid color in the lab color space, but we're just sort of trying to get the whole color space into this box. So the domain, which is the input of our scale, is going to be 0 to the width. That's the x, and then the y is going to be the canvas width. And then the y is 0 to canvas height. A lot of times you'll swap these two in the y scale because in computer graphics we start with 0 at the top, and in pretty much mathematics and physics usually 0 is at the bottom and goes up. And so one way you can do that is just swapping the domain or swapping the range. But not both, because then you won't have done anything. And so the range, that's what we're trying to figure out here. Based on these values, I think it's probably negative 100 to 100. So we just say that here. And I think the second value, so I'm talking about L and A in the lab color. We don't need semicolons. Get out of here. So what a scale does, right, is going to take a value. If I get canvas, this guy's a function. If it takes, well, let me just show you. So if I apply it to a value that's 200, so right in the middle of these two values, it's going to give me a value that's right in the middle of these two values, which is, well, which is 0. If I give it the maximum, the height, canvas height goes to negative 100. If I give it 300, I'll get, well, it already executed. How about x of, if I put in 360 into x, what am I going to get out? 100. So super simple, but it's kind of like the basis of visualization is these scales. And these could be color scales too. Oh, I could just do, you know what, I don't even need to do this nonsense here. Well, no, I'll do the nonsense first. OK, so negative 100. OK, so now these two scales are sort of just going to control the screen coordinates and give me values that are in the range. So if I apply this, if I apply the scale here, let me just put these on new lines. So rather than just passing in x, which is going to be just a pixel coordinate, right? Now it's going to be something that's within the range negative 100 to 100, which is the I think the domain of this lab function. Oh, I mean, it could be. It could be. This is the L, yeah. OK. Ooh, let's animate this. Let's try 100 here. I don't know, maybe. OK. That looks really good. Let's try 200. That looks terrible. All right, this seems to be in the lab color space. What if this is 200? Well, and this can be negative, right? OK, cool. So we seem to be roughly in the lab space. There's a third dimension to lab space, which is the B. So let's explore this B. So animation is kind of where. How about this? Let's wrap this whole thing in a function, lab space, and we pass in a B. And that B goes here. So now what we can do, well, let's let you continue seeing my code. Doesn't need to be hidden. So now what we can do is just call lab space and pick a B, and it'll re-render with that color, or with that B. Did we ever find out what B is? I just want to know. Lightness and A and B, the color opponent dimensions.
Oh, maybe you should make X and Y be the
A and B?
Yeah.
That might make sense, but iterating through lightness isn't going to be as exciting as iterating through B. OK, so I can kind of play around with this. What Ian said is rational, but this is going to look pretty. I can kind of play around with this by just picking values. But I want to use the computer just to iterate through all the values and make a pretty animation. So I'm just going to introduce D3 timer here. So D3 timer, and let's just give it. Oh, you know what? Let's use the canvas for everything. We don't need this thinking console. So fill text. Actually, I think the text that it's writing is first. So you pass it some text that you want to just write on the canvas. Pass it an X and Y coordinate. And it should just draw that text. Let's see what it does. Oh, perfect, perfect. The only thing is just rendering the text on top of itself. So let's just clear this canvas every time. OK. OK, so d3.timer. D3.timer takes a function, and it's just going to run this function over and over and over again. And really, what it's used for is well, in this case, we're pretty much just going to use it for animation. Internally, it uses something called request animation frame to sort of animate in a battery-friendly, sort of interface-friendly way. If you animated with something like set timeout, you may override user input. So your animation frames may queue up and sort of force their way onto the page and not let the user interact with anything. The whole page might freeze up or something like this. This, if there's ever a user interface sort of event in between frames, that will get precedence. That user interface event will get resolved. But the key thing here is just that it's running this function over and over again, about 60 times a second, I think. And this t here is just from the moment it started, how many milliseconds have elapsed? Looks like milliseconds. 1, 2, 3. How many milliseconds? We have milliseconds in here. So now what I want to do is I want to fit this. So again, this is sort of a input thing. I want to use this t as my b. But the b doesn't use values as big as 29,000. So what can I do here? Yeah, so let's pick a the modulus operator. What it does is basically gives you the remainder. So if I have 505 mod 100, it gives me 5. So when I do this modulus operator, it means I'm never going to get a value bigger than 100, but it's going to change really fast, right? And kind of randomly. Oh, you know what I could do is just put it in here. So I want sort of ordered values that are increasing. Whoops. Not yet, not yet. Just kind of random values. I want something that's kind of increasing sort of a slow, steady rate. So maybe divide this by 100 first, and then round. There we go. If I do 200 here. Maybe a little faster. All right, so let's try passing this number in to lab space. Oh, that's cool. The fill here is taking the last color here. What were you saying, Ian?
What if you modulus 200 and subtract 100? Is it goes from negative?
Let's just do one thing here. Let's just make the background black just so we can see these colors a little easier here. Actually, is it possible to dim just these lights? Don't everyone get up at once.
We can turn off all the lights.
Oh, but not the front ones?
You guys are okay with that?
It's fine. It's fine. You can see the subtle shades of color here. That's pretty good. So one thing with animation, right, that's kind of annoying is it's going from 0 to 100, and then it just jumps back down to 0. What is some way I could make it so that it oscillates back and forth between 0 and 100? Or let's say negative 1 and 1, and then I could just multiply by 100. add canvas height to, sorry, say that again?
Trigonometry. Creating 3 items in the domain and 3 items in the range.
Oh.
I don't know if it works.
Actually, I'm not. I'm just doing just a little bit of math down here. So in this one, the answer comes from trigonometry is the clue. I'm just applying simple functions to a number to get. I want something that oscillates between -1 and 1. Sine. Yeah. So let's apply that to. For sine, I want actually something that goes a lot slower. No. I want it. What do I want? I don't need any modulus, yeah. I do want to round out here, though. Maybe I don't need a round. Yeah, I don't want to round inside. OK, so if I do this, it's just going to change crazy fast. Oh, that looks kind of cool, huh? This should just this should give me some real feedback about what I'm doing here. B. So this number is changing just way too fast. You can just slow it down by dividing this t in here, and you'll get something that's changing nice and smooth. Let's just internalize this color space a little bit here. A little faster, little faster.
So I guess the point is that you just couldn't do this really with SVG. It would just be too slow.
You could probably do it. I think you could do it. I don't know. I don't know if there's really a point. Canvas is just kind of a different technology. We need more code. Let's step back from this grid. So you could play around with something like this with other coordinates. Let me just let's just keep this somewhere. Call it color grid. Let's try something in a different. Let's do something that Canvas is much different at. So I'm going to use most of the same stuff here. I'll use a timer to. Use a timer. I'll clear it out each time. Do I need the circle function? Nah, I don't need the circle function. So actually, yeah, let's keep the circle function. So we start. We're back at this blank spot again. Let's talk a little bit about transforms in Canvas, because transforms are cool because in Canvas you can kind of do this logo style. Logo was a sort of a little computer graphics language where you just sort of ordered this turtle around and you just kind of gave it commands. So there'd be a cursor, which is the logo turtle, and you would say move one step in this direction and then turn 30 degrees, and then move one step in this direction, and then turn 30 degrees. And you can make a circle or what's 30 degrees? Decagon, some kind of polygon by moving in a fixed increment. You could do that kind of stuff. You could go in circles without trigonometry because you just turn a little bit and move forward, and then turn a little bit and move forward. And if you do that an infinite number of times, or very small little increments, you basically make a circle. And there's no cosine or sine. It's just little changes. And you can do this kind of stuff with Canvas, with translate and rotate. So let's start just with the basics of translate. Let's translate just so instead of 0, 0 being at the top left, let's move it to the middle. So we translate the whole context by the width divided by 2 and the height divided by 2. And then if we draw a circle, this is where we use this function. change this back to XY. Ah. I guess we could do it that way. I guess we can. Where X is 0 and Y is 0 and R is 10. Whoa. Why does that happen? We get a circle in the middle of the page. Why is it just 3/4 of a circle and not a whole circle? Ah, because of this clear rect down here. Here, let me just make that bigger so everyone can see what's happening here. Oh, too big, too big. So what's happening? Can anyone figure out what's happening? Why this is happening? Let's just slow it down here. Oh, no, that's not going to help. Why do I start with 3/4 of a circle, and then why does the circle slowly disappear? It's these two lines. It's this one right here, this one right here, and then this is also part of the story. This font is not part of the story. You wanted me to draw a rectangle somewhere, Ian?
Yeah.
Where do I draw it?
Instead of the clearing, like I want to draw like a blue rectangle.
Okay, so let's fill rects. Fill styles. Let's make it a nice beige. Oh, you know what? We can make it RGBA. Is a nice little touch. So we can have transparent rectangles here. Not make it white?
Or yeah, like at least some other color because your circle's white. Right?
All right, let's make it hot pink maybe. How hot will this pink be? Does it make it any clearer? Let's maybe stroke the rectangle instead. Maybe that would make it a little clearer. Let's make the stroke style lime green is a nice color. And just stroke this rect as well. Is stroke rect a thing? It is, right? This is some cool moire patterns happening here. So what's happening? So why in the original example, if we just go back, why I was surprised at the beginning here, is once you apply a translate on the canvas, everything after that is going to be translated. So that translate just sticks around. Like you move there and you're there. Everything that you do after that happens relative to there. So when I cleared a rectangle at the coordinate 0, 0, I'm starting from the middle of the screen, so the top left of the screen, and clearing a box that actually goes. This clear rect actually is going to go. It's going to go right off the screen over here. And so it clears this, and then this rotate right here just starts spinning it around. Well, shouldn't have walked up here. Just start spinning it around the central axis. So what I wanted to do is sort of make like a little radar effect here, which we're pretty close to doing. So let's just let's fill rect. So I want to make a little thin line that goes around. So this is XY. I do want to start at the middle. Yeah, let's just draw all the way to the right and just make it about a 2 pixel line. And we don't need the circle anymore. So we just established, the circle is just to establish that we're in the middle of the screen. OK. So this is pretty sweet. I need to rotate just a little slower. I just want it to sort of cover, yeah, just cover this space. Excellent. So I want to get kind of like that radar sweeping effect. And this is where you can do some neat stuff with transparency. So what you can do here is, so this right here is a little sweeping line. And what we can do is we can set the fill style to black, so RGBA 000. And I want the opacity to be, well, let's start with 1 just so we can see what's happening each step. And then this one I want to fill, because I'm centered, I want to go minus canvas width divided by 2, canvas height divided by 2, canvas width. Oh, I just see on the screen here. Canvas height. So this is the X. X. So that moves over up, moves over here. The Y moves up to the top left of the screen, and then canvas width, canvas height will fill it normally. And so what this does is, oh yeah. So what these guys just explained to me, I should explain why it's a problem. So when I set the fill style black here, everything that runs after that is going to be black. So when it goes back to draw my sweeping line again, the sweeping line is not white anymore, it's black. So just every time step I have to set it back to white to get my sweeping line to be white. And this is not working. Oh, yeah. Starts at negative canvas height. Wait a minute. Okay, let's talk about, let's talk about canvas state here. So there's some tricks. So what I want to do is just fill erect 0, 0, canvas width, canvas height. I want to just fill it original as if it wasn't transformed at all. So what we can do here is we can save the canvas state whenever we want with its save method, and we can restore it whenever we want. Down here, how do I? Yeah, wait a minute. Well, what I could do is just make this a function of t. Oh, it stacks, right. Let's see what this does. Excellent. Okay, so what this does is it's saving. So save saves the, basically wherever it's translated. All the translations and rotations can be combined into a matrix, which is just is sort of the translated rotated state that it's at. So there's always some matrix that describes the canvas's current state. And what save does is just sort of saves that state. And what restore does is it goes back and loads that state back up. So up here it was translated. So we saved it before it was translated. So when we restore, we get it untranslated again. Although rotate still seems to be doing its thing. So let's. Put the translate after the fill rect. Yeah, I guess so. Let's look this up, how this works. Canvas, save, and restore. I think it is a stacked-based thing. Here we go, a stack of drawing states. So save pushes the current state onto the stack, restore pops the top state on the stack, restoring the context to that state. Oh, I don't know. I forget how to do. My mind's blanking here. Let's do this a different way. Put what before the rotate again?
Victor was saying that if you put the save before the rotate name.
I believe it before the translate also.
Okay, so put one here and put one here. Well, now it's going to restore, but it's going to be. All right, no, I failed. I failed at that thing. Let's just use a. Ah, that's so terrible. Okay, let's go back to when I wasn't trying any of this trickery. We're going back here because I give up. Okay, this is where I want to save the unrotated state, and this is where I want to restore it. And we'll just do this once each time. And then for the rotation, let's just make this a function of t. And this clearing actually has to happen before I sweep. Could save it up here. ctx.restore. If I save it here, restore there, this is actually pretty close to what I want. That's very close to what I want. Okay. Too slow. Okay, so man, this makes my brain hurt. Why is it doing what it's doing right now? Without any save and restore, so my save and restore are useless, basically, is what it's telling me. Okay, this is what I want, and now this is. Okay, so I finally successfully used save and restore. So this saves the state that is before it's right after it's translated. So I still have to do this action. So this restore basically what it does is it always undoes this rotate, and now I've made this rotation a function of time. So it rotates. It just redoes the whole rotation every time step rather than rotating incrementally. But the unrotated canvas is always the one that's saved and restored. So basically save and restore just sort of skipping this and letting me clear this canvas each time without the clearing canvas also rotating around. So let's get it going a little faster. I don't need this thinking modulus. And then I can get this cool sweeping effect by just adding lowering the alpha of the rectangle that's clearing this. So I get this sort of nice, nice sweeping thing. Rotate goes from 0 to 2 pi, right? So how do I make this? Or just rotate once every second. 1, 2. I think that's pretty much it. How about all the it doesn't have enough intermediate frames. I guess let's rotate twice a second, or once every 2 seconds. Once every 4 seconds. 1, 2, 3, 4. Perfect. Yeah.
What happens if you make the rotating maximum 5?
That looks pretty good. Okay, so yeah, let's do multiple contexts. Let's just leave this and yeah, just do two canvases. So my canvas 2. Let's just have multiple script tags. So just copy this whole script tag and replace, call this canvas 2, context 2, my canvas 2. No, we're not going to have multiple script tags. We're just going to have 2 canvas contexts. I'll put them on top of each other here. So let's just say all canvases are, whoa, what is that? Position absolute, top 0, left 0. So we should still have one back here. Let's just try drawing a you guys are on it. So you could totally have multiple canvas contexts, and so the canvases themselves are DOM elements. So so they do have, for instance, a Z index. So if I say that so if this one has a Z index of, let's make this fill style blue instead of white, so it's easier to distinguish. So you see right now this blue is going underneath the pink. But if we change the Z indexes, oh, I hope this works. Oh, why does that happen? Anyone tell me why that's happening? It's because the way I'm getting this sweeping effect is I'm just filling a rectangle that's a black rectangle. Actually, I may still need the fill and restores here, or the save and restores. So I have just black ring. What's getting that cool fade out effect is just every iteration I'm throwing a rectangle that's black and it's got 10% opacity just over the whole canvas. And eventually, it just becomes solid black and just blocks out the canvas behind it. But when the other one's on top, obviously it doesn't do that. So if this is one here, the second canvas is just floating on the first one. Yeah, I think so. So okay, so this is a cool one. Global alpha is sort of a global opacity for everything that gets drawn. So it's kind of like setting RGBA to 0.5 for everything. So it's like pink with 50% opacity. And if we do this, we should be able to see the blue pass underneath it. Yeah, did you see that? Let's just make this really big. So yeah, that is possible, but all right, I want to show you something else here. Let's actually just draw this on the first canvas because I want to show you the compositing modes, which are pretty cool. So here I just moved the pink back onto the first canvas because when you're on the same canvas, you have access to special compositing modes. The compositing modes let you know when you have a pixel already on the page and you have another pixel coming in because you're filling or you're stroking, how the two colors are going to get combined. So normally you just kind of render on top. It's called source over, I think. So if you have blue that's 50%, it's just kind of it's almost like it's a piece of glass that's sitting on top. But there's other ways to combine these colors. So let's set the global alpha here. So this makes them transparent, and it's the global composite operation that lets you do this. So by default, it's source over, I'm pretty sure. If it was destination over, I believe that means that the blue will render behind. So new stuff actually renders behind earlier stuff. So my sweeping line is actually getting rendered behind the black rectangle that's fading everything out. The cool ones, Zor is pretty cool. So Zor, oh, that's not very cool at all. Let's get rid of global alpha, maybe. Well, Zor is a bit let down. Let's try lighter. It's because it's rendering every. OK, for now, we're just going to clear rect because we're interested in the way that these things combine.
Maybe if you applied it to the pink instead of the
applied what to the pink?
The global composite operation.
So the global composite operation is actually a property of the canvas. So everything that is rendered into the canvas, while that's declared, is going to use that. So what lighter does is it actually combines the two colors in a way that brings you closer to white. So if you have some red and some, so like if you layer like a dark green over a dark red, the dark green won't make the red darker. It'll actually just combine the R and G channels and get it lighter. Actually, I could just show you that specifically by making this red and this green. I think it'll turn yellow or orange. So lighter does that. Darker is a cool one. Darker. Maybe darker is a cool one when the background is white, actually. How is that different than source over? Let's just compare this side by side. Looks kind of similar to me. OK, Ian's sensing that time is waning. All right, let's do it. Let me just show you kind of how the composite modes work with. Oh my goodness. So this is like a little page that I made a while ago that has some links on just some basic patterns. Actually, I think most of these aren't D3 patterns. Under the hood, this is actually what D3 Timer is kind of doing. It's using request animation frame to make an animation loop. What I wanted to find here, though, is this So the different compositing modes, whoa. All right, well, it's still here. The different compositing modes, so source over, this red is the second one that's drawn. Wow, what's on my laptop looks a lot different than what's up there, but that's fine. Source over just draws on top. Source in, I don't know what these do exactly. So yeah, this is an intersection. This is an outer section.
Wow.
What is this?
The intersection of just of the top.
Lighter and darker to. Lighter and darker sort of combine colors in different ways. Zor, what is technically? Zor literally just takes like the color bits and Zors them, right? I don't know, but the way I use this is these compositing modes are quite useful in visualizations, like real visualizations, when you have a lot of data. So if you're going to render some thousands of lines on top of each other, to get a sense of the density of the lines, you can use alpha, and you can use these different compositing modes to here we go. So I believe in this one I use, this one actually may just be, maybe, may just be source over. So in a visualization like this where you have lines intersecting, if you change the canvas context, I might be able to just hack the page. Hack the page. Will this just give me one node or all the nodes? Oh. Oh, yeah, you're right. Let me just refresh this page and fix this. So when I change the composite mode, you see sort of what effect it has. So with lighter, as lines combine, and as you sort of accumulate all the colors from these different multicolored lines, you kind of get this neon effect, and because just wherever all the colors combine, you basically get white. If we change this to darker, this is just a little hacky line of code I'm doing to go through and just change all the canvases, because darker looks generally good on like a dark background or dark background. You could use dark on a dark background if you want combining to somehow fade to black. And so this one just makes the intersections just kind of approach black where they're very dense. So those are two cool things you can't do so easily in SVG because does SVG support compositing? Yeah, there are SVG filters, but I don't know if there's compositing in this way. Only in Firefox? You can get way more control in WebGL, but this is really easy to do. It's the cool thing about this. It's just setting global composite operation and picking one of the 16 values that looks cool. And you can get a lot of cool effects with Zor and lighter and darker. Let me just quickly run you through a couple other cool things you can do with Canvas. So we get to the lightning talks here. This is one that Mike Bossack made that actually renders out little images. So D3.geo actually has a built-in Canvas renderer, so you can pass it a context rather than, I forget what you pass it when you're with SVG. With SVG, it somehow creates a line generator, and you render SVG lines. But with this, you just pass it a canvas context, and d3.geo knows how to render things to canvas. And in this one, it actually saves, it renders out for each month, for each year, it renders out a full United States. And then for each year, it saves all the 12 months just in JavaScript is in memory. And uses put image data to just iterate through. Once it's rendered them all out, they're kind of like PNGs or JPEGs, or I think closer to PNGs. But it's just image data, and you don't need to render it again. You can just put image data, just throw it right on the canvas. And so you can do cool stuff like that. These are a bunch of examples that Mike did that are mazes, so it's sort of color filling. This is something that is where Canvas makes a lot of sense to use. There's another d3.geo example. Oh, so there's one more thing that I wanted to just quickly touch on. We won't go through a code example here because not 100% on my game right now. But so the thing about Canvas is the Canvas doesn't create any elements. So if you want to create interactions with elements that you've rendered, you have to be kind of tricky about it. One thing you can do, so if we had our grid example, right? Why can I not just open a page? In this color grid example, what's a super easy way that I can find out which of these circles I'm hovered over? Yeah, you can use the x, y coordinates. And actually, we created scales, so you can literally just invert the scales to get back at to get back to your range, or the initial domain, sorry, that you started in. So you can get from screen coordinates to, oh no, we didn't use a scale to position them. Let's just look at that code really quick. I forget what we did. Oh, we created it with D3 range. So they're in increments of 10. If you divide it by 10, you would have the index of the circle that you're on. And if you save that in an array or a variable somewhere, you could use that index to look it back up. So on a grid, it's easy to look something up. On a map like this, it's a little tougher in what you can, but it's possible to add interactions. So this is a projected world. And so the trick here you can do is you render the world once where each country is a totally different color. And then you render, but this is a hidden canvas. This is, canvases don't need to be rendered to the page. They can just be sort of in memory hidden. And you take the x, y coordinate here. You invert the projection so you get back to latitude, longitude coordinates. And then on this one, you can use the latitude, longitude coordinates to look up a color value. And if you've saved all these, as you're rendering these out, you say, United States is, the red value is 125. You just create an object that points 125 to your United States data object. And now you have a lookup. So you can go back. You can invert from x, y to latitude, longitude. You go from latitude, longitude to a color down here. And the color maps to an object that gives you your data value. So as many colors as you can render, you can have that many objects. And as long as you can, whatever you're displaying, you can invert it to something that actually, you don't even necessarily need to invert it. You could have just projected. I mean, this right here could literally be the same projection. It's just colored red. But the advantage here is that I only need to render this once. Does that make any sense?
Are you saying that the second map is a lookup table?
The second map is a lookup table, yeah. If you followed me, the cool thing about this is the trick works with almost any visualization, right? Because it's just the rendered elements are, you're just rendering the elements twice, and one of them just serves as a lookup table. So it could also be a force-directed diagram where every one of the nodes is a different color, and use that color lookup as a way to get back at your data, and you no longer need to have objects for each node. So it's a cool little hack. It actually works really well. It's quite fast and only uses 2 elements rather than 1 element for every country. So it's a trick. Simon promised there'd be tricks. And that's the bell. Any other questions you guys have about Canvas? There's just kind of a rundown of various things about Canvas. I hope you guys take it on your own and play around with it. Yeah, the other context is a WebGL context. Oh, is there a WebCL context as well? Is that a Canvas? I don't know if it's a Canvas context. Mm-hmm. The other Canvas context is WebGL. It's a lot more work to initialize it. Yeah, it's called WebGL, and there's a whole lot of more work to set it up to get something like this. It's not something we could go through quickly. If you're interested in WebGL, though, I recommend checking out the library 3.js. Because it'll just get you started easier. WebGL has a lot of sort of boilerplate, and it is I mean, it's just sort of like all this graphics technology that just accumulated a lot of baggage. It's not that easy to get started with.
Have you played around with asm.js at all? ASM.js, whatever it's called.
I have not, no. This is like a optimized subset of JavaScript that can run on the GPU or something?
Yeah, so you just compile C into an optimized subset of JavaScript. So there's no garbage collection.
Actually, if you're interested in WebGL and you enjoyed the Canvas kind of stuff, a cool place to start is just GLSL, which is the shader language. So shaders are it's kind of a function that gets run for every pixel on the page. If you want to learn, I'm not going to explain it right now, but if you want to learn about it, GLSL.js is a really nice place to start. This beginner tutorial is about half an hour long, and it'll get you the basics. It's kind of just like Canvas, but almost coming from the other direction. And GLSL runs on the GPU. It's super fast. OK, cool. That's all. Time for lightning talks.